All right, I think we're good. So what I want to do today is that I want to go over 2, maybe 3, depending on how fast we go, since if we don't get whatever example I go over today, I'll also upload the example problem with the solution on Moodle later on Moodle later on today, so you'll have access to them. We'll see how many of them we can go through. I have 3. I'm hoping that at least we covered up until the end of the second one. We'll see how it goes. And they're related to homogeneous compound homogeneous transformation. I just want to give you some examples of how things work. I kind of talked about it when we were talking about the example in the last class, that example for SCARA robot arm. Well, same story, but just needs more practice to get a sense of how to do rotations and translations to get to the point we want from where we are, and make sure that we get the direction of axes right and we get the transformation matrix right. So I'm going to start with something relatively simple. I don't have a feature for that. So let's go with, let's write it this way. Example. And I'll just draw it. This is X, Y, Z coordinates. And let's call this one X naught, Y naught, Z naught as our first coordinate system. And I have the second one. Let's draw it this color. As, let's put it here, X, maybe it's too far to left. I'll just put it right here, X, Y, and Z. I'll call this, this is, I think is X1. This is, if this is X, this should be Y1. And this is Z1. I can write it as Z there, Z1. And let's get the location. I'm going to try to draw this as straight as I can. Yeah, not very straight. Let's put it this way and then this way. This line is the extension of x-axis, obviously, comes here. And this point is, oops, right color. This point is 4. This point is -3. And this height is 7. From here to there, I can draw it. I can probably do a better job by saying this is 7, or maybe worse job, depends on how you interpret the outcome of this. All right, so what is the problem statement? Problem statement is telling us that we have a transformation, or we're looking for a transformation matrix that can transform coordinates from, I'll call this B, I'll call this G, X naught, Y naught, Z naught, and I'll call this B, X1, Y1, Z1. Let's write it this way. Find the transformation matrix that, let's write it this way, that can transform coordinates from B, X1, Y1, Z1 to G, X0, Y0, Z0. Okay. I made very ugly here. 7. Oh my goodness. Somebody save you from me, guys. This drawing. All right, so I'm gonna put 7 here, being the height. All right, so here's what we do. Similar to what I said before, but now keep in mind, steps. We start now. Here is G. G is being global coordinate frame, being B being local coordinate frame. We go from we want to find a transformation matrix that can transform the coordinates from B, if you know the coordinate of a point in local coordinate frame or body frame B. You want to know what is that coordinates, what are those coordinates of that point in global frame G. So what we said is that the way you look at this is that you start your body frame or put your body frame exactly where your global frame is, or you put your secondary frame exactly where your first frame is at the beginning. So they should be exactly on top of each other, axes in the same directions. So here is what you do. You start from there. You say, well, that's where my use a better color. That's where my local frame or body frame was at the beginning. X1, Y1, Z1. Now the transformation matrix, what was the transformation matrix? We said the transformation matrix in this case, let me just write it first, from frame B to frame G, all right, let's put it this way, from B to G would be a rotation matrix of B in G, and then the translation of the origin is called in global coordinate frame, 0 and then 1. Right? That was the global the transformation matrix. Now, in order to form this transformation matrix, we have to find this R and this G, this D. Right? The translation. Translation is pretty straightforward. You can even write it now. It's where the origin of your body frame is in your global coordinate frame, or the coordinates of the origin of your body frame, if you can think about this as O1, in your global coordinate frame. Right? That you can find out hopefully easily. You'll look into it. But the tricky part is to get this R matrix right. And this is the rotation that your body frame should go through to go from where it was to where it is. Right? So when you have something like this, you start, as I put it here, you start your body frame as a frame that is aligned with your global frame, or your secondary frame that is aligned with your initial frame or fixed frame. Now you start thinking about what rotations you have to go through, or what rotations this body frame at its initial position has to go through to make all three axes in the same direction as the axes are at the end position, at this position. So we do all the rotations, make sure that the axes are in the right orientation, X, Y, Z, X1, Y1, Z1, and then do the translation at the end. It's always the case, always. Find all the rotations you need to force your frame, body frame to go through to get the axes in the same direction as the axes at the end or at the current position of body frame. So in this case, my X1, if you look at the magenta color here, I think it's magenta or whatever you want to call it, and the gray color, like these two axes, forget about the blue one, right? The blue one just gives me where the body frame is, and I need that also to figure out the rotation. The goal is to go from magenta, the color, or pink, whatever you want to call it, to gray. Now, to go from that to gray, right, where B is initially, right, you can call it B prime or whatever you want to call it, where B is initially, to where B is at the end. First, we have to figure out all the rotations that this B prime or B at the beginning has to go through to make sure that the axes x1, y1, z1 are aligned with the axes x1, y1, z1 in gray. And then we do the translation. How do you figure that out? Well, you have to look and figure it out. There is no formula for that.
It's intuition, you know, that inner feeling that you get in your stomach. It tells you. I'm making a joke. Okay.
I didn't hear the first. Yeah. It's intuition, pretty much. You have to look at it and it has to talk to you. Let's put it this way.
Yeah.
You look at enough of these, you'll get the hang of it. Now, how do we do that? You start rotating the axis. You start rotating your body frame, where it is at the beginning, around global axis, or the original or the fixed frame, and see where it takes you. And remember, the approaches that you follow might not be unique, right? There is usually more than one way to get to where you are, from where you are to where you should be, right? From the magenta color to gray color, gray axis. Here is what I do in this case. Let's do this one and see if it makes sense. In this case, I'll rotate this. Remember, this magenta, I have to rotate it enough around axes multiple times, most of the time, to get the axes aligned with the axes in gray color, and then do the translation. So what I do is that I'm going to rotate this B prime, right, where the body frame is, 90 degrees. And remember, all the rotations should be about, this is something that I'm giving you a lot of things at once, but you have to remember that all the rotations have to be about your fixed frame. This is your fixed frame, global frame. So remember that doesn't matter where your body frame is, your rotations are always about your the axis of this fixed frame. So let's just do this and then we'll figure it out. Me giving more information, I think, is going to help at this point. So first, I'm going to rotate this B prime, I called it, and where it is, about Z naught, 90 degrees, positive. Remember, positive. Thumb shows Z naught, 4 fingers, the direction of the rotation. So if I rotate this in 90 degrees, it's the rotation in positive direction. If I rotate that 90 degrees, here's what I get. Let's see if I can clean this. So remember, x1 is along x naught, y1 is along y naught, and z1 is along z naught. Right? So that's where I started. Now I'm going to clean this as good as I can. If I rotate this around z naught 90 degrees, my x1 gets here. Right? Let me fix that. Maybe I should keep it here. So I'm confusing myself. So x1, y1, z1. We'll see how crowded it gets there. If I rotate this 90 degrees about z1, when y1 comes here, x1 goes there, and z1 stays where it is. This is 0. So I rotated the magenta 90 degrees about z-axis. Now this is x1, y1, z1. The green is the new position or the orientation of x1, y1, z1. Still, this is not in the same direction that I want. Now, to get this right, I need to do another rotation. Remember, this green should be in the same order as gray. So I do a rotation about z naught for 90 degrees. I want to make sure that I did it correctly. x1, y1, z1. Now, to get this in the right direction, did I put it? It's too early in the morning. All right, so I did Z naught 90 degrees. So I get Y1 there, X1 there, and Z1 there.
Dr. Masumi,
I'm confusing. Go ahead, Mike.
why can't we just do first rotate about the x-axis 90 degrees and then about the y-axis 180 degrees?
I'm doubting what. Let me just look at my note. Maybe I made a mistake there. So I did rotation about z-axis. That's a great start, huh? Rotation about z naught. I just want to try figure out what I did because there is more than one way. So that I can assure you. Right? It's just one approach. So what you are saying, Michael, is rotate about x 90 degrees. That's what you're saying, and then rotate about y 90 degrees, right?
180.
Let me just do my own approach, then we'll do yours. So rotation about z-axis, z-naught axis, assuming that I did it right here somewhere, I didn't make a mistake, which I'm doubting it more and more. We get x1, y1 there, x1 there, and z1 there. And then I did a rotation about y-axis 90 degrees. I have no idea why did I do that. Could be very much that I made a mistake. So let me do what I did next, second approach. I'm sorry, guys. It's again not a very good start. You learn by learning, not doing what I did. All right. It's not talking to me, as I said, apparently. So let me do the approach that I did, second approach. Then we'll see. Then we'll do what you say, Michael. See, because it's more than one approach. So what I did again, let me see. Hopefully this time I did it right. But y-axis 90 degrees. So x1, z1. Maybe I didn't made a mistake. I see what mistake I made. My approach is not wrong, but I did a mistake somewhere here. Sorry, guys. This should be y naught. That's what happens when. Okay, this should be x naught. Okay, now it's actually a right angle. That's correct. All right. Almost there. That's a great start. So this is x1, this is y1. All right, I just made a mistake that right, it should be going x to y, z. All right, hopefully that, now it makes sense. If it doesn't, I'm just gonna quit today from teaching robotics. No, I scratched that. I'm not gonna stand by that, what I said. All right, so we start from the orientation. I just changed the orientation of global frame because it was wrong. It should be right hand rule. Going from x to y should go to z. So I start by 90 degrees direct rotation about z. I get this as, okay, now it is starting to make sense. This is x1. This is y1. And then this one is z1. This becomes z1. So green is the orientation of axis when you do 90 degrees rotation about z. Now, and remember, all the rotations should happen around global coordinate axes. So I do 90 degrees about z-axis. And after that, I do 90 degrees about y naught. Right? So now this is my new frame. I have to draw this at least for the first one. Make sure that everybody follows, including myself, apparently. So this is y naught, this is x naught, this is z naught, and now here is what we have. We have x1, y1, and z1. So we have x1, y1, z1, and remember, this is where we want to be. This is the orientation that we want to be. X1, z1, y1. So once I get here, now I'm going to have another rotation, right, in about y naught, and the rotations happen or occur along global axis. So I do another 90 degrees rotation about y naught. If I do that, here is the new orientation would be. This would be x1, this, and this. We'll see how much this becomes x1. Well, rotation is happening on y1, so x1 stays the same. This becomes y1, and this becomes z1. So, yes, I saved myself. So, rotation 90 degrees about z-axis, we got to the green orientation. Another rotation 90 degrees about y naught. Now, what happens is the orange coordinate frame, or the axes of those that coordinate frame, are in the same direction, or are in the same direction as the gray coordinate frame. So I got the orientation right with two rotations. So here is what I did. If you want to think about this approach, here's what I did. I did rotation about z naught axis 90 degrees. So it's r z naught. I can do this, z naught 90 degrees. Then I did another rotation around y naught. So rotation about y naught axis. So r y naught 90 degrees. Right now, orientation is good. Now, what I need to do is just do the translation. Take it from where it is to where it should go, from here to here. This would be my translation. dg. And remember, d, everything is in global coordinate frame. So d would be the whatever is the vector going from where the origin is at the beginning to where the origin is at the end. That vector represented in global coordinate frame, or blue coordinate system here. So the third one would be translation to dg. And dg, the vector, well, I gave you the coordinate in global coordinate frame at the beginning, gray value. So that's 4, -3, and 7 transpose. You write the vectors in this direction. So once you know that, you can actually write this. Now, this one, this rotation matrix right here comes from these two rotations. So you have to find the rotation matrix first, and whatever that is after these two rotations, and then plug it into the transformation matrix. And remember, when we were talking about rotations, we said when we have multiple rotations, we start from the last one. Right? We say that rotation from B to G is basically the second rotation times the first rotation. Here is R from B to G is the second rotation we had, which is basically R y naught 90 degrees multiplied by R z naught 90 degrees. We already know these, right? We learned from before with these rotation matrices, so we can just plug in the values. The first one is rotation about y-axis, so that'll give you cosine, and the rotation is 90 degrees. Cosine 90 degrees, then 0, then sine 90 degrees, 0, 1, 0, and that one should be sine, actually this is y, so this is minus sine 90 degrees, 0, cosine 90 degrees. This becomes the first one. This becomes R y naught 90 degrees. Multiply that by the second bond. I'm just going to write it here. So ugly matrix. There we go. This one, z 90 degrees positive, so that becomes cosine 90 degrees minus sine 90 degrees 0, sine 90 degrees, cosine 90 degrees 0, and then 0, 0, 1, since it's in z, rotation about z-axis. Well, these values are actually pretty straightforward. Cosine 90 degrees and sine 90 degrees, we can just pretty much plug in the values as 0 and 1 and minus 1, so it makes the multiplication pretty easy, I would say. Cosine, this is 0, sine, it's 1, 1, this is minus 1, right? This is minus 1, and this is also 0. Cosine 90 degrees, again, it's 0. I just want to make sure we did the right rotation. 90 degrees in z, so it becomes 0. Yeah, minus 1. This is 1, and this is 0. So that becomes 2, I would say, simple 3 by 3 matrices, the operation. All right, and this is your R z naught and 90 degrees. If you do this multiplication 3 by 3, it gives you the rotation matrix for the whole rotation. So that will give you R BG as, I'll write it here. You'll get, I have to find an answer somewhere. You can find it. I'll give you 0, 0, 1, 0. I think this is 1. Yes, this is 1, 0, 0, and 0, 1, 0. We're just basically multiplying two matrices, a bunch of 0 and 1s. You know, RBG, you get your transformation matrix, or DG. Well, DG, I already put it there, so I can write the transformation matrix for you here. So T becomes a 4 by 4 matrix, right? The top elements, top left, the 3 by 3 matrix, that would be 0, 0, 1. 1, 0, 0, 0, 1, 0. This row is always 0, and this is 1. And here you put your DG, which basically is 4 minus 3, 7. So 4 minus 3, 7. All right. So the tricky part, this is your transformation matrix from B to G. So this is what transforms the coordinates of any point in B frame to G frame. So the tricky part is to find out the rotations that you have to go through. Now, as I said, this is not the only, it's not a unique, there is no unique way of doing it. Usually there are 2, sometimes 3, multiple approaches to go from where the coordinate frame is to where it should be at the end. All right. In this case, I think I found another approach. You might find a different one. The second approach, I found out that if you start from, let's say, approach 2, let's call this approach 1. For the second approach, if you start from, let's put it this way. Right, then this is, this time I have to get this right. What did I put? Y naught, X naught, Y naught, Z naught, right? Before I confuse myself. X naught, Y naught, Z naught. Right? So this is G, X naught, Y naught, Z naught. And then here where you are at the end, or where you should be. So this becomes x1, y1. Not really. That's what we got. x1, y1, z1. So x1, y1, z1. So starting from where we are, all right, this is aligned with x1, y1, z1. Now the second approach I just could think about was rotating around y naught 90 degrees and rotating around x naught 90 degrees. Right? This is what I'm saying. So if you rotate around y naught for 90 degrees, your y1 stays the same. You will get z1 here, and you will get x1 downward. Now in the new orientation, do another rotation about x1 positive, like 90 degrees. I'll just draw it on the same. Being lazy, I don't want to draw this again. So 90 degrees. So you get to, I'm going to draw it longer. x1 comes up. y1 goes where z1 was. You're doing 90 degrees. Look at the green one. I know it's crowded there. Look at the green one is where we are, and we want to make sure that the green one is in the same orientation as the gray one. So I'm going to do a 90 degrees rotation about x naught. So x1 comes up, x1 comes where y1 is, y1, green y1 goes where the orange y1 is, right? And this is going to be your z1 because your z1 doesn't change. So z1, assuming that this where your z1 was. So let me just write it here. Approach 2, rotation about y naught, rotation about y naught axis, what are y naught and 90 degrees positive. So we went from magenta to green. Now green is the new orientation. We do another rotation, right? This would be a rotation about x naught axis. So r x naught 90 degrees. Now the orange is the correct orientation. x1, y1, z1 in orange is in the same orientation as x1, y1, z1 in gray. So orientation is right. We got the orientation right using these two rotations. Now we do the translation. Translation doesn't really change. It's the same as before. You go from where the origin is to where the origin should be. dg, that's the, this vector should be represented in global coordinate frame. So translation to let's call this O1 translation. Translation, maybe 2 is not the right word. Translation using dg, and that was, I have it there, 4 minus 3 7 transpose. Right? The same story. Actually, you get the same thing if you go for rotation. Remember, rotation matrix in your transformation matrix is coming from this two. So your rotation from B to G is rotation. The second one comes first. So you're going to get Rx naught 90 degrees. Very ugly. Rx naught 90 degrees multiplied by Ry naught 90 degrees. X naught 90 degrees, well, you write the rotation matrix for that, right? That was, I'm gonna fit it here, or try to fit it here. There we go. The component was that it was X naught, so X naught would be 0 1 0 0. Okay, so it would be 1 0, 0, 0, 0. This is cosine 90 degrees minus sine 90 degrees. Then this becomes sine 90 degrees, and this becomes cosine 90 degrees. That's the ugliest cosine I've seen. Cosine 90 degrees. All right, so this becomes your, and let me move this here, 0 and 0. So this is our x 90 degrees. Rotation for positive 90 degrees about x-axis. And our y, you'll get, I'll fit it here. Don't hate me for this. You get, I can just write the final thing. So it's going to be 0, 0, 0. So let's just write it this way. It's going to be 0, 0, 1, 0, 1, 0, and this becomes, so it's going to be minus 1, 0, 0. I just plugged in the values. Lazy there. So this becomes our rotation y naught 90 degrees. All right. You do this multiplication. I'll just leave the rest to you. And you can form the transformation matrix by knowing R BG DG 0, 1. This should be the same as what you got here. So this one and this one are the same. You can do the math and figure that out. All right, this becomes, just to give you the elements there, hopefully you know the cosine and sine. This is 0, this is minus 1, this is 0 and 1, and this is 0. So just a 3 by 3, 3 by 3 matrix multiplication. Whatever you get, put it there, and DG, you already know that. You form a transformation matrix. And that transformation matrix is pretty much the same as what you get from the first approach. So here is the general procedure. You start from your global coordinate frame, wherever your global coordinate frame is, or your first frame is. You want to go from the first one to second. You start with that and go over rotations. How to figure out the rotations? As long as you don't confuse yourself like what I did at the beginning, which, believe me, happens way more frequent than you think. Go over the rotations, go through the rotations, and make sure the axes are oriented correctly in a way that they should be at the end or in the second frame. And then do the translation. Now, keep in mind, you always do rotations about the first frame, the frame that you assume is fixed. Here, I did a rotation about y naught for 90 degrees. I went from the magenta to green. Now, when I wanted to do the second rotation, I still made this rotation about the axis of the blue coordinate system. See that? It doesn't matter where you are after this second rotation. You have to still think of a rotation about the axis of the first frame or fixed frame or global frame. So I said, well, now a rotation about 90 degrees about blue x naught. Just keep that in mind. Don't keep following your body frame and make rotations about its axis. You are making rotations and translation. Everything is about your fixed frame. All right, question on this one, folks. Did that make sense what I did there? The approaches I followed, the explanation I gave. If it didn't, tell me so I can try to explain it a different way. Now you might be able to find a different approach. I don't know, I didn't look. There might be a third approach here to get the orientation. These are the two approaches I could think about. Question on this one. So there is really nothing new, I would say. we haven't really talked about anything new since a week ago, or more than a week ago. All there is to basically look into it and figure out how can you form your transformation matrix by going over one, sometimes two, you will see sometimes even three rotations, and then make the translation. Right? But later on, when we start talking about robotic arms after the midterm, after the exam, you will see that we come up with the general approach, how to go from one frame to another frame in a robotic arm, which is like a unique way of doing it, because we're going to define coordinates frames and do these transformations. So there is no confusion that, oh, which approach I have to take. Over there, it's that is more organized. Right? Somebody came up with a set of rules how to set your coordinate frames and how to make rotations to make sure that everybody gets almost the same transformation matrix, or everybody follows the same approach. All right. Transformation matrix is always the same. It does the same thing for you. All right, so let's look at something more aligned with what we do in this course. All right, if there is no question on that, I can bring something more interesting. Here's an arm. Let's see if I want to talk about this one or the other one. I'm a little unorganized today, apparently. Let's talk about this. Then I'll post the, we'll see how many of these we can go to. I am very unorganized today, so let's move this here. I have to go back and forth between pages of this. So example, now we have this arm, you see on the left side, is a revolute joint. Rotation is represented by V naught, V1. You can just look at it as V1, or you can just look at it as theta 1 written in a weird way. V1, there is a revolute joint here, it's axis of the joint. There is another revolute joint here, rotation V2, and then there is a prismatic joint, sliding back and forth, D3. On the left side, you will see the axis attached to this cord, to these links, or the different parts of this arm. Now, the problem statement is telling us that, well, this is the figure, right? This is a robot manipulator with coordinate frames we put there. Right? Frame G, what you need to know is this one. Let's call this G. G, X naught, Y naught, Z naught. This frame is fixed, right? So you, of course, I made it proud of that. This frame is is fixed. So G, X naught, Y naught, Z. Frame G, X naught, Y naught, Z naught is fixed, right? And consider these coordinate frames x1, y1, z1, x2, y2, z2, and x3, y3, z3. And we'll go through what we are asked to find. So A, we are asked to find the transformation matrix from frame x1, y1, z1 to x0, y0, z0, from B, let's call it B x1, y1, z1 to G x0, y0, z0. Part B, the transformation matrix from x to y to z2 to x1, y1, z1. So the transformation matrix from B x2, y2, z2. We can call this B1 and B2 if it makes it better. 2 B1, x1, y1, z1. Let's see if we can do these two, then I'll go over the third one. So currently what we're looking at here, this is x naught, y naught, z naught for part A. X naught, y naught, z naught. And I want to find the transformation to x1, y1, z1. Forget about everything else that you see in this frame for now. Y1, z1. Now this is a little trickier because now you have one orientation, 90 degrees, and then you have to take into account the rotation of the revolute joint. So we want to go from black to magenta. What orientation do you suggest I do to get the, what rotation do you suggest I do to get the orientations right? That shows pretty much most of the class didn't follow what they say in the first half.
I think we should revolve around the x-axis.
We
90
go,
degrees.
exactly. So we go 90 degrees around that. So first, this is part A. So A, rotation about x naught for 90 degrees. So that would be r x naught 90 degrees. Now if we do that, here is what we get. I'm going to make it messy. Be ready. We'll do this one, and then we do 90 degrees. So here's what we get. This becomes x1. I started, I didn't put the original frame there, but it started as x1, y1, and z1. This is where I started. Let me probably should do it at the first few ones. So this is x1, y1, z1. That's where I started. I do rotation about x naught for 90 degrees. Right? This rotation. X naught and x1 are, well, it's rotation around x1, x naught. So x1 stays in the same direction. Y1 goes up. This is y1. And then z1 comes here. Almost did the rotation there. Now, the second rotation would be, well, we want to make sure that this is aligned with x1, y1, z1. And since this is a revolute joint, it can rotate with v1. So if we rotate this green axis, v1 amount about z naught, we'll get these two aligned. So here is the second rotation. I don't put it there, so it's already messy. So rotation about z naught for v1 degrees, or theta 1. That's written weirdly, so I'll just go with v1. Or z naught v1. Rotate the green coordinate or axis, green coordinate system about z naught. It's written in black, the original coordinate or fixed frame, in this case, between these two frames. V1 amount, because that's the revolute joint, right? Rotates in positive direction V1. So we have a rotation about Z naught V1. That is the rotation that you have to go through. So this is the rotation you need from going from 0 to 1, or the other way around to convert the coordinates frame. 0 to 1, or 1 to 0.
Wait, so we have to say that we rotate something 0 degrees?
No, we are not rotating 0 degrees yet. The green, the light green is where it is after 90 degrees about x naught, right?
Yeah.
Now, once we get there, now we have this V. If you look at the light green right there, and this magenta here, there is still some rotation between them. Still x1, these two x1s are not aligned. You have to rotate V1 amount. That's how much the rotation is happening because of this revolute joint. Right? This is because of the, now we are in a robot arm instead of just a coordinate system. So you have to get the orientations right first with whatever it is, and then you have to take into account the rotation or translation, possible rotation or translation because of that joint.
Okay.
It makes sense.
Yeah. Theta 1.
So yeah, you get theta 1 or V1 as we call it.
Okay.
So we're going to have two rotations. Previously, the axes were fixed right here. There is no arm there. There is no joint there. Right. So we just go with what we have. But in this case, you have an arm. You have to make sure that you also take into account the rotation for the joint. So you get the R01 here, and that one would be R. You start from the end, R Z0 V1 times R X0 90 degrees. You get that one. Then once you get that one right, let me see if I can draw it here. I'm gonna make it very ugly there, so I don't do it. Hopefully you see it. This is the rotation that's happening because of V1. I'm really straining myself. Around Z. Green coordinate rotates around Z0, black Z axis, V1 amount. Once you get your rotation right now you do your translation. The translation would be going from where the origin is to where it should be, and that's L1 right here. This is L1 going up. So it's L1 along Z0. If you want to think about what you get there, I'm going to put it right here. Translation along Z0. This becomes D, let's call it D in 0 coordinate frame, or G, is 0, 0, and that's L1 transpose. That's your translation. These matrices, I try to just fit it here so you actually see everything in the same place. Or Z0 V1 is a rotation about Z0 axis, global frame, V1 degrees. You can think about that. That would be cosine V1. Let me use C and S for cosine and sine. You can fit it here. Cosine V1 minus sine V1, 0. Right? This becomes sine V1, cosine V1, 0, and 0, 0, 1. So rotation about Z. Rotation around X, well, this is 0, 0, 0. This is 0, 0. Then we have X, so this becomes cosine 90 degrees minus sine 90 degrees, sine 90 degrees, cosine 90 degrees. You get the rotation by multiplying these two matrices. Once you know that, your translation from 0 to 1, I have to put that the other way, we're coordinating, changing the coordinates from 0 to 1, is R and then D 0, 1. Right, then you can just, I can give you the final answer when you do the multiplication. Make sure you get the right value. Cosine V1 0 minus sine V1 0 sine V1 0 cosine V1 0 0 1 0 0 and then 0 0 0 1. Oh, this is actually L1. So that would be your translation matrix for part A. Transformation from B1 to G. And you start from where G is, find the orientation, that gives you the rotation matrix. Once you know the rotation matrix, find the translation, and you're done. Let's look at the part B, transformation matrix from B2 to B1. This is something that you have to keep practicing until you get comfortable with. So right now, so let's let me keep this here in case you need the notes. I'll bring the picture here and we do it again on this. So we're doing part B. In this one, just look at these ones. You have x1, y1, z1, x1, y1, z1, and you're going to x2, y2, z2. We're going to this. We're going to z2, x2, y2. This can be written here. Let me double check I didn't make any mistake. You're going to x1 from x1, y1, z1 to x2, y2, z2. Y2, z2. All right. How do we do this one? That's a little tricky. You start from where x1, y1, z1 is. Remember, you're going, that's what, now the original frame that you have to keep it fixed is x1, y1, z1. And you start from there. You have to get into the frame written, drawn in magenta, x2, y2, z2. There is that V2 orientation there. This one, that is because of this revolute joint. But before that, we have to correct the orientation of this. How do we fix the orientation of this? How do we go from, here is what we have. Draw it here in a bigger scale. We have x1, y1, z1. And we get into the purple. You want to get into purple. Magenta. I don't know why it's simple. This is where we are at the beginning. Let me use a different color that now we're using magenta. This is where we are at the beginning. They're aligned. X2, Z2, Y2. Is more than one approach. At least two I know. Forget about that V2 rotation for now and assume that this magenta color X2, Y2, Z2 are aligned here. Just imagine that there is no that final rotation, that they are Z2 and X2 are a little tilted. Just forget about that final, because that's happening because of V2 or theta 2. Now, forgetting about that, how do we go from the gray to magenta? Right? There is no translation happening in this case, so only thing we have is rotation. All right, not a good sign. So a couple of ways you can do that. One way is to do one rotation. There's two ways I see. To do one rotation about Z1 for 90 degrees and another one about Y1. So if I do 90 degrees about Z1 like this, Z2 stays here. Then you have these. You have X2 and you have Y2. And then you can have a 9-degree rotation about Y1 right there. 90 degrees rotation about Y1, which brings your axis to this becomes this, this, and this, where it should be. This becomes X2. We're going from green to orange. So this becomes X2. This becomes Z2. And then this becomes Y2. So we started from where the gray was. It's buried underneath that. 90 degrees about Z1. That was the first rotation I went through. I get into where the light green is, X2, Y2, Z2, right? Z2 doesn't change, X2 goes up, Y2 goes the negative direction. Then from there, I do another 90 degrees rotation with Y1, shown by orange. I get to X2, Y2, Z2 in orange, and that's the correct direction. Before I apply this theta 2 orientation, before I apply this one. Okay. Once we get there, these two rotations, the third rotation would be V2, and it's going to be around Z1, around Z1. So here is what I'm doing here. Rotation about Z1 is what I did for 90 degrees. Is positive, obviously. So this becomes RZ1 90 degrees. I do another rotation, right? Rotation about Y1 for 90 degrees, or Y1 90 degrees. And then the third one would be just the revolute joint. That's rotation about Z1 for theta 1 or V1. I'll just go with V1, that I wrote everything as V. V1, which means that becomes R Z1. That's actually V2, right? This is V2. So you get your rotation matrix by multiplying 3 rotation matrices, right? Going from transforming the coordinates from 2 to 1, right? gives, you can find this by starting from the last one as the first multiplication, right? That part hopefully you remember. When we have multiple rotations, we start from the last one, RZ1 V2 multiplied by R Y1 90 degrees multiplied by RZ 90 degrees.
I have a question.
Go ahead.
When two things are in the same direction, like, you know, like we have two rotations around Z, we can't just add them together.
If they are, we don't have it here. Do we have one that is
We have
on?
about Z1 for 90 and about Z1 for V2.
Well, order matters. If these 1 and 3 were one after another, you could do it. But right now you have one rotation. You have this one that is not about Z1, right? It's about Y1. Since we do matrix multiplication, you can't jump. The order matters, so you have to do the last rotation when you're doing multiplication, then the one before, and then the one before that.
Okay.
But if they weren't in a row, yes, you could just put them together, obviously. But
Okay.
here, if you do the switch, you're going to get the wrong transformation matrix. Right? So you get R Z1 V2 multiplied by R Y1 90 degrees multiplied by R Z1 90 degrees. I don't know why I put negative there. This just 90 degrees. Right? It's just a typo from my side. Oh, it's supposed to be comma. And -90 degrees and V2. And there is no translation. So by the end, you will just get the transformation matrix, which is a combination of those. I can give you the final transformation matrix T from 2 to 1 would be R 2 to 1, D 0 and 1. If you do those multiplications, you get the 4 by 4 matrix right there. First a 3 by 3 would be your rotation. What you get from your rotation, which will be minus sine V2, 0, cosine V2, cosine V2, 0, sine V2, 0, 1, 0, and 0, 0, 0. And at the end, because there is no translation, these components are 0. Your D in 2 is basically 0, 0, 0. All right. What time is it? Here is a question.